Now there are certain functions for which you can actually you can just substitute a over here. Okay, so there are many functions like that for which this will work. Okay, so we'll call this direct substitution property. Okay, so if you want to find this limit, you can just simply substitute it here and you'll get it. Okay, so we'll call this direct substitution property, and this property is true for all the polynomials and the rational functions. Okay, so direct substitution property, which is substitution property, okay, which says that this is f of a, okay, is true for many functions, okay, including polynomials and rational functions. So basically it is true for polynomials, that's for sure. Okay, and it is true for rational functions. Okay, okay, and it is also true for actually trigonometric functions. Okay, but as long as a is in the domain of f. Okay, so it's true for polynomials, rational functions, when a is in the domain of. Is that clear? Okay. Fine. Okay, so let's just see if we can find the limit. Okay, suppose I want to find this limit. Okay, so what can I do with this? Well, since I'm interested in the limit, I don't really care about what happens at 1. Okay, I agree it's a rational function. Okay, but I cannot just substitute 1 here because 1 is not in the domain of this rational function. Okay, so this is a requirement, right? A is in the domain. Okay, so so can I do something with it so that yeah, so that we can simplify this and get the limit. So what I can do is I can replace it with some function which is exactly like this, but its behavior at 1 is different. Okay, like for example, at 1 this particular function is not defined, but I can always convert it into a function which is exactly like this function, but its behavior at 1 will be different from this one. Okay, so how can I do that? Well, I can write the numerator like this. Okay, and then observe that wherever this function is not equal to 1, I can cancel this, right? I mean, cancellation is valid. So I'm going to get something like this. Okay, is that fine? Okay, so what is the difference between this function and this function? Actually, they are the same everywhere except at 1. Okay, they are, if you plot this function and if you plot this function, they'll both be same. Let me just do that for you. Okay, so this is a straight line like this. Okay, okay, so this is x plus 1. Okay, and if I draw this one, it will be exactly this. The only difference is that there'll be a hole at 1 because this function is not defined at 1, and elsewhere it's just going to coincide with x plus 1. Is that okay? Fine. Now what I can do is this, that I can use the direct substitution property on this because it's a linear function, so it's a polynomial. I can just substitute 1 here and I'll get 2. Okay, so that's the limit. Okay, so that's the limit of this, and since the behavior of this particular function is same as the behavior of this particular function except at 1, so the limit will coincide. I mean, it's going to be the same limit. Okay, so this particular function and this particular function has the same limit. Okay,